In this video, we're going to be looking at the top half of page 2 of D5, and we're focusing on vertical and horizontal shifts. And in this particular example, we're going to be looking at a horizontal shift, which can also be called a phase shift. Whenever we're talking about sines and cosines, the horizontal shift is often called a phase shift. So once again, what we'll do is first identify the amplitude, the period, and the phase shift of the function. Then we'll graph one period, and then we'll state the domain and the range. So for the amplitude, remember the amplitude is determined by the coefficient that's out here in front of the cosine. It's just the absolute value of that value, so the amplitude will be 1. The period, if you recall, is influenced by the coefficient of x, which in this case is also 1. The period, remember, is 2 pi divided by the absolute value of b, which is 1, so this is just going to be 2 pi. The horizontal shift, because it's x plus 4, so based on our experience that we've had before with looking at transformations of graphs, because it's plus 4, we know that it's going to go to the left pi over 4. So what we want to do is take that information and sketch one period of this particular function. So we can start with the fact that there's no vertical shift on this, and there's no change in the amplitude from the parent function for cosine. And so that means that since there's no vertical shift, the principal axis will still be the x-axis, and we know that the amplitude is 1, so that means that we'll go up 1 and down 1, so down to -1. Now, the period of this is still 2 pi, but the entire graph, if we take a look at the cosine graph does this, and the entire graph is going to shift over pi over 4 to the left. So in other words, this point is now going to come over here. This point will move, and so everything will move over pi over 4. So this is an approximation of what our new graph will look like, but we want to have actual values on the x-axis. So what I recommend that you do whenever you do a shift is before you start actually putting the numbers on this axis, I would go off to the side, or I'm going to go down below here, and actually calculate what those values are. All right, so we know that usually the starting value for this period is 0 for x, but that's going to shift pi over 4 to the left, which means that the x-coordinate, the new x-coordinate for this is going to be negative pi over 4. So I'm going to come down here, and we'll just start out with negative pi over 4, and then we want to come up with the other 4 values that we need. So again, beginning, middle, end, the quarter point, and the 3/4 point. And there are certainly different ways that you can approach this, but I'm just going to stick to one particular method just to keep this video fairly short. So what we can do with this is say that the entire period is 2 pi. And we know that whenever we're doing these graphs, we're always taking that period and dividing it into 4 sections. And it corresponds to the 4 sections here, 1, 2, 3, 4. So if I take 2 pi and divide it by 4, that's equal to pi over 2. And so that means that each of these jumps has to be pi over 2. So what I can do is just successfully add pi over 2 down the line. So I'm going to add pi over 2, but pi over 2 is 2 pi over 4, and that's going to be a more convenient form since I'm starting with negative pi over 4. So when I add on the first one, negative pi over 4 plus 2 pi over 4 is pi over 4. If I add on 2 pi over 4 again, then this next value is going to be 3 pi over 4. Add 2 pi over 4 again, and so that's going to be 5 pi over 4. And then add 2 pi over 4 a final time, and that gives me 7 pi over 4. And what I recommend that you do also is double check the period. So from here to here, that should be a total of 2 pi. And you can get that just by subtracting. You could just kind of use some common sense. From negative pi to 0 is, or from negative pi over 4 to 0 is pi over 4. And then from 0 to 7 pi over 4 would be, of course, 7 pi over 4. When you add those, you'll get 8 pi over 4, which is 2 pi. Or you could also just subtract 7 pi over 4 minus a negative pi over 4 is the same as plus pi over 4, which gives you 8 pi over 4, which is 2 pi. And so that helps you double check to make sure that the period is correct. Now that you have those values, now I would go back and put those onto the axis, and that way we can make sure that they're evenly spaced and that we have the right number of tick marks in the negative side and the right number on the positive side. So we're going to start with negative pi over 4. I'm going to switch to a finer pen here. So negative pi over 4. Our next value is pi over 4. So I'm just going to go over here and put pi over 4. And then remember, this is just 1/4 of this total period on the x-axis. And so if I just kind of estimate that, I'm going to come over here. The halfway point then will be at 3 pi over 4. Go a similar distance. The 3/4 point will be at 5 pi over 4. And then the last one will be at 7 pi over 4. So that's going to define for us the left and the right of the graph. The 1 and the -1 define the top and the bottom. And so again, what we have is kind of a little box, and our graph has to go into that box. Remember that the midline is the x-axis. And so because we're graphing a cosine graph we know starts and ends at the high points. At the high point, this is the starting point over here. So it's going to start here, end here. The middle is here, and that's going to be a low point. And then the 1/4 point and the 3/4 point will be on the principal axis. And because this behaves like cosine, it's just going to look like this. And as always, I do recommend that you check that on your graphing calculator. When you put the function in for your x min, you'll put in negative pi over 4, x max 7 pi over 4, y min -1, y max 1.